At 2:47 a.m., Lieutenant Commander Viktor Petrov watches his sonar screen aboard the Russian frigate Admiral Makarov, anchored in Sevastopol's inner harbor. The display shows normal patterns, commercial traffic entering the outer bay, patrol boats maintaining their circuits, the familiar acoustic signatures of a naval base at rest. 23 meters below the surface, something moves through the darkness at 4 knots. It weighs 800 kilograms, costs $42,000 to build, and carries 300 kilograms of high explosive. In 17 minutes, it will detonate against the Makarov's hull, initiating the most devastating naval attack in the Black Sea since World War II. This isn't a torpedo. It's not a mine. It's an autonomous underwater vehicle built in a converted warehouse using commercial components and open-source software. Behind it, 11 more follow in coordinated formation, their navigation systems linked through encrypted acoustic modems that the Russian Navy's sophisticated electronic warfare suites cannot detect or jam. The attack on Sevastopol represents 18 months of Ukrainian innovation, turning civilian maritime technology into weapons that would cost traditional defense contractors millions to develop. Tonight, 12 underwater drones worth $500,000 total will engage Russian naval assets valued at $4 billion. The mathematics of asymmetric warfare have never been more stark. 6 weeks earlier, in an industrial district outside Odessa, Ukrainian naval engineers complete final testing on their latest generation of maritime strike platforms. These aren't the surface drones that grabbed headlines in 2023. These units operate completely submerged, invisible to radar, thermal imaging, and visual observation. The design philosophy is radical simplicity. Commercial diving equipment provides pressure hulls rated to 100 meters depth. Lithium-ion batteries from electric vehicles supply 72 hours of operational endurance. Navigation comes from a combination of inertial measurement units and pre-programmed waypoints, eliminating the need for GPS that could be jammed or spoofed. Most critically, the vehicles communicate through acoustic signals that mimic marine mammal calls. Russian sonar operators, trained to filter out biological noise, unconsciously dismiss these communications as dolphin pods common in the Black Sea. The encrypted data packets hide within frequencies that naval sensors classify as background ocean noise. Each drone costs less than a luxury car to manufacture. The explosive payload comes from repurposed naval mines. The guidance systems use smartphone processors running custom firmware. The acoustic modems are modified from commercial underwater survey equipment. Nothing requires specialized military contractors or restricted technology. Ukrainian intelligence has been mapping Sevastopol harbor for months using commercial satellite imagery, open-source ship tracking data, and reports from sympathizers within occupied Crimea. They know where each Russian vessel anchors, the patrol patterns of harbor security, the blind spots in sonar coverage created by commercial traffic. The strike package targets 4 primary objectives: the Admiral Makarov, a $3 billion frigate serving as fleet flagship; the Kaliber missile storage facility on the eastern pier, holding 60 cruise missiles worth $120 million; 2 Rapucha-class landing ships loaded with ammunition and vehicles for amphibious operations; and the submarine repair dock where the Kilo-class submarine Stary Oskol undergoes maintenance with its hull opened for equipment replacement. At 2:54 a.m., the first indication of trouble comes from an unexpected source. A harbor seal colony on the southern breakwater suddenly erupts in panic, dozens of animals launching themselves into the water. The duty officer at Harbor Control notes it in his log as unusual animal behavior, possibly caused by an underwater tremor. He's partially correct. The tremor comes from 12 underwater drones accelerating through their final approach, their electric motors creating vibrations that marine mammals instinctively flee. 3 minutes pass. On the Admiral Makarov, Petrov notices a faint acoustic anomaly on his passive sonar. The signature doesn't match any known vessel or weapon system in the threat library. It sounds almost biological, like a pod of dolphins using echolocation, but the pattern is too regular, too purposeful. He requests permission to go active with the ship's main sonar array. Permission denied. Active sonar would wake every admiral in Sevastopol, and the last junior officer who cried wolf about underwater threats found himself transferred to a supply depot in Siberia. Petrov continues monitoring on passive systems, watching the anomaly approach at 4 knots, still unable to classify it as hostile. At 3:04 a.m., the lead drone passes beneath the harbor's anti-submarine net. The net, designed to stop traditional submarines and torpedoes, has gaps near the seafloor to allow tidal flow and prevent damage from storms. The drones, programmed with centimeter-level accuracy, thread through these gaps like needles through fabric. The first weapon reaches the Admiral Makarov at 3:07 a.m. Its magnetic sensors detect the frigate's steel hull from 8 meters away, triggering the terminal guidance phase. The drone angles upward, accelerating to 12 knots. For maximum kinetic impact, 300 kilograms of modern explosive compound, equivalent to 450 kilograms of TNT, detonates against the hull, precisely at the waterline. The explosion tears a hole 6 meters wide through the Makarov's port side. Seawater floods into the engine room at 4,000 gallons per second. The ship immediately lists 15 degrees as damage control teams scramble in darkness. The blast having knocked out primary power, emergency generators kick in 30 seconds later, revealing the full scope of catastrophe. The engine room is already half flooded, water rising toward the main electrical distribution panels. Before the Makarov's crew can send a distress signal, the second and third drones impact. One strikes the ammunition magazine forward of the bridge, the other hits the fuel bunkers amidships. The magazine doesn't detonate immediately, modern safety systems preventing a catastrophic explosion, but the concussion cracks the magazine's flooding valves. Seawater begins mixing with exposed propellant charges, creating toxic gases that force evacuation of the forward sections. The fuel bunker strike is more dramatic. 40,000 liters of marine diesel spray through ruptured tanks, coating the water surface around the ship. When emergency flares automatically deploy, they ignite the fuel slick. Within seconds, the Admiral Makarov is surrounded by a ring of fire, cutting off several escape routes for the crew, now abandoning ship. At 3:11 a.m., 4 drones reach the Kaliber missile storage facility. This is not a ship, but a reinforced concrete structure built to withstand aerial bombardment. The drones can't penetrate the bunker directly. They don't need to. They target the loading equipment, the hydraulic systems that move missiles from storage to ships, and most critically, the bunker's ventilation system. When 300 kilograms of explosive detonates inside a ventilation shaft, the overpressure travels through the entire air handling system like a shotgun blast through a pipe. Every filter, every fan, every duct junction explodes outward. The bunker remains structurally intact, but functionally destroyed. Without ventilation, temperature and humidity will destroy the sensitive electronics in the Kaliber missiles within days. 60 cruise missiles, each worth $2 million, are rendered unusable without firing a shot. The Rapucha-class landing ships, Cesar Kunikov and Novocherkassk, are struck simultaneously at 3:14 a.m. These ships, loaded with ammunition for the southern front, create secondary explosions visible from space. The Cesar Kunikov carries 120 tons of artillery shells in its vehicle deck. When the drone's explosion ruptures the deck plating, those shells begin cooking off in a chain reaction that will continue for 6 hours. The Novocherkassk suffers an even more catastrophic fate. The drone strikes its fuel system while refueling. Operations are underway, with fuel lines connected to shore facilities. The explosion ignites not just the ship's fuel, but also the shoreside storage tanks. 800,000 liters of diesel fuel burn in a conflagration that spreads to 3 adjacent piers, destroying patrol boats, tugboats, and maintenance vessels caught in the inferno. At 3:17 a.m., the final drone reaches the submarine repair dock. The Stary Oskol sits helpless, its hull cut open for reactor maintenance, its crew reduced to a skeleton watch of 6 engineers. The drone detonates beneath the submarine's keel, lifting the 3,000-ton vessel 4 meters before dropping it back onto the dock's support blocks. The impact breaks the submarine's spine, cracking the pressure hull in 3 places. Repair will take 2 years and cost $300 million if Russia decides it's even worth attempting. By 3:20 a.m., Sevastopol harbor is chaos incarnate. The Admiral Makarov is sinking, its crew abandoning ship into waters covered with burning fuel. The missile storage facility's alarms shriek as temperature sensors detect the spreading fires. 2 landing ships burn out of control, their ammunition cooking off in staccato explosions that shower the harbor with shrapnel. The submarine lies broken on its dock like a beached whale, reactor engineers frantically executing emergency shutdown procedures to prevent a nuclear incident. Harbor defense finally responds, but to what? The attack is already over. The drones are gone, their mission complete. Patrol boats race through the harbor, searchlights sweeping, guns firing at shadows and debris. 2 boats collide in the smoke and darkness, adding to the casualty list. Helicopters launch from the naval air station, their thermal cameras revealing nothing but burning ships and spreading oil slicks. Admiral Osipov, commander of the Black Sea Fleet, arrives at harbor control at 3:35 a.m. Through the smoke-stained windows, he watches his fleet burn. The tactical display shows 12 confirmed strikes, 0 attackers intercepted, 0 attackers even properly identified. His operations officer reports the damage assessment still climbing. 4 capital ships destroyed or severely damaged, shore facilities burning, ammunition continuing to explode across the eastern pier. The numbers are staggering. In 23 minutes, Ukraine has inflicted over $4 billion in damage using weapons that cost less than a middle-class house. The Admiral Makarov alone represents a $3 billion loss. The submarine will require $300 million in repairs if salvageable. The 2 landing ships and their cargo total $400 million. The cruise missiles in the damaged bunker $120 million. Secondary damage to facilities and smaller vessels still being calculated, but estimated at over $200 million. By dawn, satellite imagery reveals the full extent of devastation. The Admiral. Makarov rests on the harbor bottom, only its superstructure above water. Both landing ships are burnt-out hulks, their ammunition still sporadically detonating. The submarine repair dock is twisted wreckage, the Stereoskol's hull visibly broken. The strategic implications extend far beyond material losses. Every Russian naval vessel in the Black Sea must now assume it's being stalked by invisible underwater predators. Ships can no longer safely anchor, forcing continuous movement that burns fuel and exhausts crews. Port facilities require massive investment in underwater detection systems that may not even work against these small, quiet threats. Ukraine achieves strategic sea denial without possessing a single major warship. The Black Sea becomes a no-man's water where 12 drones worth $500,000 drove out a fleet worth billions. The technology proliferates immediately. Within weeks, detailed specifications appear on encrypted channels worldwide. The design is deliberately open source, using only commercial components. Any competent engineering team with a machine shop can now build similar systems. Naval strategists from Washington to Beijing study the attack with growing alarm. If Ukraine can do this with converted civilian technology, what happens when state actors deploy purpose-built systems? Every harbor becomes vulnerable to attacks costing thousands but inflicting billions in damage. If you found this analysis of modern naval warfare valuable, make sure to hit that like button and subscribe to the channel. Turn on notifications so you never miss our deep dives into the tactics and technologies reshaping military strategy. Drop a comment below with your thoughts on asymmetric naval warfare. In Moscow, emergency meetings continue through the night. How do you defend against an enemy that can mass-produce precision weapons in converted warehouses? How do you maintain sea control when every fishing boat could deploy underwater drones? The questions have no good answers. Russia's naval doctrine, built over decades and costing trillions of rubles, has been invalidated in 23 minutes by Ukrainian engineers working with commercial catalogs and open-source software. This is the new reality of naval warfare, not battleships exchanging salvos or submarines stalking carriers, but swarms of cheap, smart robots turning harbors into graveyards. The side that adapts fastest controls the seas. Ukraine has demonstrated that innovation beats tradition, that mathematics beats mass, that a small nation with limited resources can neutralize a major power's naval force through creative application of commercial technology. The lesson reverberates through every admiralty on Earth. As sunrise illuminates the still-burning wreckage of Sevastopol harbor, one thing becomes crystal clear. The balance of power at sea no longer depends on who has the most ships, but on who has the smartest engineers. And tonight, Ukraine's engineers just rewrote 300 years of naval doctrine with 12 robots that think dolphins sound nice.